Hi everybody, welcome back. So I kind of have to admit, this is not one of my favorite receivers. This series, it's a Technics SA-800, and I've never seen an SA-1000 in person, but looking at pictures of it, it looks to be a lot more high quality, build quality than these. I'm just not real keen on it. The serviceability of the controls in the front is not real easy. As you'll see inside, the circuit boards are they kind of remind me of those Hong Kong Chinese transistor radios, that dark brown circuit board that's kind of thin and brittle. And it's loaded with capacitors, those little blue capacitors that will leak, and ruin the boards. This one doesn't appear to be having those problems. As a matter of fact, it fully functions. So I think we'll see, what all we have to do. It's obviously you're going to want to do a recap on it and clean the controls, but the whole amp works. The receiver, everything works perfectly and really doesn't need anything other than maintenance. So maybe this will be more of a solder and chat type video as I go through the recap. And I'll post it for those of you who like those kinds of videos. And maybe we'll go over a little bit of some of the unique features. There are a couple things in these that doesn't exist on other amps. For instance, how it has two power supply levels based on the impedance of the load. So for instance, if you connect an 8 ohm speaker, it will actually allow a higher voltage on the output transistors to give you more voltage swing than if you connect, for instance, a 4 ohms load. So if you connect a 4 ohm set of speakers, a relay comes in, it brings in a lower voltage tap on your power transformer, and your DC voltage is lower on the outputs, if I remember correctly. We'll look on the schematic and verify that if I'm wrong or if I'm right. And the whole purpose of that is to limit the overcurrent on the outputs and so forth. So it should limit distortion, and it also should protect the receiver from overload. Now that's kind of cheesy in my opinion. Just put a bigger power transformer in it. I guess it's a cost thing. It's cheaper to build that little circuit and add it in there than to invest in a much larger power transformer and so forth. But it is what it is. So again, I don't mean to offend anybody who really likes these, but it's kind of disappointed me because Technics equipment, however you want to say it, is usually super high quality. If you look at any of the equipment that they released to the Japanese market, like the SE series and things, they are absolute works of art. They are extremely good build quality, super good specifications, just high quality all around. You look at this, you can see it was made for a lower cost market, I guess. But anyhow, that's enough of my opinion. Let's take it apart and take a look at it and see what we've got. Okay, like I said, this is going to be more of a solder and chat video than it is, a repair video, because there's no repairs that really needed on this thing. It's in relatively clean condition. So we'll just go over some of the features of it and maybe recap it and have a little bit of fun while we're doing it. I will admit that I have not been able to put much time in on this bench as of lately, and probably until the first of the year I won't get as much time as I normally do because of work and just so many things going on right now. So we'll do this one, and then I have at least one more power amplifier, or not power amplifier, integrated amplifier video that should be a good one, and possibly one more kind of receiver in this kind of classification of things that I'll do before the end of the year. And that one might be a little more interesting because I think it has issues and we'll have to troubleshoot it. So anyway, let's move the camera over and look at the internals of this. And as I said, it has these boards that are just really flimsy. And if you notice, all of the controls are just buried. If I move the camera over here, they're just buried down in there, and very hard to get to clean them. So that'll be a little bit of a challenge. The transformer for the power supply is not bad, but remember, this is a 125 watt per channel amplifier. And really all you have is these two filter caps here. It's this rather small transformer for what it's being asked to do, because it's not just a power amp, but it's the preamp, it's a tuner, you know, everything all in one. So that's probably why they made that choice to put that limited power supply, or, you know, power limiting, voltage limiting rail or whatever. Couple things that I don't know. I'm going to look online for some pictures. I think this is factory, but it is kind of strange. If you look, well, let's see if we can get in here a little better. You can see how these just have some crimps. So you have the windings coming straight off of the transformers, and they have that heat-proof, you know, shielding, whatever you want to call it, that nylon stuff, Teflon, whatever. And then it's crimped onto a normal wire, and they're only connecting it to, like, you know, a couple inch long piece of wire and then going onto the board. Same thing with the inputs. So that's kind of interesting. I'm assuming this must be a fuse or something in here. I don't know. We'll look on the schematics. But needless to say, it's just kind of an interesting design how they did this. Looking down here, there are two relays. One of them is your typical speaker protect relay that you would see in just about any amp. The other one is the one that actually does the switching of the power rails. Now don't get confused between, you know, like a Class G or Class H amp where you have rail switching or multiple power. That's not how this works. When you first turn this thing on, it kind of looks at the load that's connected to the amplifier, and if it sees a certain DC resistance between, you know, below a certain threshold, the relay will pull in and it will lower the power tap on there. And let's see if I can show you that on a schematic. Hold on a second. Okay, hopefully this is clear enough to see. But looking, here's your power transformer, here's the input. And you do have some of them will have jumpers for different voltage, but this one is for the US market only, so it only has a single primary. And then you see the secondaries here, and you can see this relay, and it switches between these taps. So you have the outermost taps, gives you the highest voltage, which are the, what is it, the orange wire, and what's this one down here? Yeah, the orange wires, and then the blue wires, no, the green wires, blue wires right here, see the blue? Those are the reduced voltage tap. And you can see how they go into here, and this relay can select which voltage you're applying. So all you're doing is just limiting the maximum voltage to the amplifier circuit so that you essentially limit the maximum current that it can deliver into a load, because when you reduce the voltage, you know, you reduce the maximum current that you can have. Ohm's law. So it's kind of an interesting thing. Again, I question why they did this, other than cost. I would argue if you just left it as is. Most amplifiers, let's see what we have here. I haven't even really looked very closely at this. Most amplifiers will have a overcurrent protect circuit in there. But if you look in here, I'll have to really kind of blow this up a little bit on the computer and analyze it a little more closely, but it appears that this does not have an overcurrent protect circuit in it. Now, again, I have not Yeah, it doesn't appear to have that. So as you know, well, let's see if we can find a schematic real quick. Okay, so this was handy, so I just grabbed it at random. But this is the phase linear 700. We just did a video series on it. And if you look here, you have these two transistors here, the 2N5551 or FPN3569 and this 2N5401 or FPN4355. And these serve with along with these diodes here as an overcurrent protection circuit. So what happens is, I've explained this many times in other videos, but essentially if you have an overcurrent situation, which is sensed by the voltage drop across this, these begin to turn on. And as these turn on, if you notice, this is the input to your drivers and your voltage amplification section, your VAS. This will actually take this down to the center point, which will essentially reduce this level here. So it'll clamp this down so that this can't turn on any further to your outputs, and therefore it limits the maximum current out to the speakers. So it's a current limiting circuit. And they call it overload protection. Almost all of the amps from this era, you know, the bigger ones especially, will have that little circuit in there. And on these ones, you don't see that really. I mean, you have your bias circuit, and that's all. And then the rest of it has to do with your input pair and your voltage amplification, your drivers, and your outputs. So it's really a very short, direct audio path. I guess there's advantages to that, but you don't have an overload protect circuit in here. And I think that's why they chose to use this little sensing circuit. And I believe that's this thing down here. We'll go over this in more detail later after I take more time to look at it. And this is what controls these relays, you know, the relays which will limit the maximum voltage to the outputs. So if I put a lower voltage to the outputs, it reduces the maximum amount of power I can put out to my speakers. That's all. Kind of a really confusing way to do it, don't you think? But here we are. Okay, we'll turn this on, and you should hear some relay action as it kind of looks at the speakers. Matter of fact, let's try something that I have not tried on this. I'm going to disconnect the speakers, and I'm going to connect them to my dummy load. All right, just like this. And what I'm going to do is, right now it's set to 8 ohms. So we have an 8 ohm load on there. And let's take a look at these relays in here. I'll turn this on. Okay, and that was the protect relay that just came in. And then let's go over here. Okay, so right now this relay, which is the speaker protect relay, is pulled in. And this one down here, which is the DC rail select, is out. And we're on an 8 ohm load. So I'm going to walk around here to my load select, and we are going to bring in 4 ohms. So now we have a 4 ohm load, and what should happen is this should pull in down here, and it doesn't appear that it has. So let's turn it off, and let's turn it back on with the 4 ohm load. There, do you see it just pulled in? Okay, so apparently it does not do that unless it's on power up. And there's a whole theory of operation how this circuit works. So see, it comes in when I turn the power on. Now this time it didn't. Yeah, there it goes. See it? So keep that in mind. I'm going to go back to 8 ohms. So we're back to 8 ohms now. And let's turn it on again. And you'll see this will not come in now. And it does not. And again, this relay, I'm using my finger. I can get in here. This relay connects to these wires. So you have the orange and the blue wires. And those are the ones that this relay will select between the two sets of wires. So that's it. Okay, as you can see, I have my Klipsch tower speakers now connected to the amplifier. And I believe these are 8 ohm speakers, and I could be wrong, but I know that they're like a nominal 8 ohm speaker. But when I turn this on, you can see that pulls in and it goes into low power mode. So technically the speakers that I have, I'll turn it off. You see it drops out and pulls right back in. So you can see the speakers that I have connected right now are not going to get the full power supply rails. So it's going to limit the power, maximum power to these speakers. Now that threshold again is adjustable. So we can change that in this, but they have very specific a very specific procedure how to do it because they are afraid that you will overload the power supply. So I'm going to start Stranger Danger up. And you can hear how it works pretty good. I mean, everything works. Again, I tried all of the controls. Other than these three being dirty and needing to be cleaned, everything works in here as advertised. So really, this is going to be a cleaning and recap job. But I thought, again, that power select circuit was interesting enough to do this type of video on it. So let's now go in and start to do the recap. And we'll just do a solder and chat. And I don't know what I'm going to talk about. You know me. Who knows where it's going to go. I'm just going to work and say what comes to mind. All right. Okay, let's start by removing the amplifier board. We'll get it out of here so it's easier to work on the power supply down below. Get this stuff out of the way. The other good thing about making videos about this stuff is you can go back, I can go back through my video footage and actually see where things were connected to put them back if I forget. Sometimes I also take photographs, you know, just use my camera phone and take a picture of something if it's of particular complexity. There we go. I often get asked about these lights that I use, like I have this one right here. And all I can say is IKEA is your friend. They have all kinds of lighting like this for these things. Okay, take that out. Loosen the screw over here. And this should come right out now, I hope. There we go. It just plugs in. I do like that. That's convenient. You can see there's quite a few capacitors on there. We'll have to get those. They don't look corroded or anything like that. So this might be pretty good condition so far. Okay, so just let's do a little test on this to get an assessment of how badly we need to replace these caps. We'll just do a little sample of the first couple we pull. So this one, here's a brand new one, 3.3 microfarads. And you can see the ESR is about 7.8 ohms. And again, we're only testing it at 120 hertz, so the ESR normally as a standard test is done at 100 kilohertz. But we have something to compare, that's all I care about. And it is spot on 3.3 mics. And go to the one that we took out. And so it's reading a little bit high, and the ESR is reading higher. It's not bad, but it just shows you that this capacitor is starting to chemically go flat, get tired, whatever you want to say. So it's not going to hurt to replace them. I mean, I'll check a couple more off camera, but for the most part, I think we're doing a good thing by replacing them. Okay, you always want to be aware when you pull these caps out. It's mind-numbing, and sometimes you won't think. You'll just kind of go through it and then all of a sudden realize that you did something wrong. And here's one of those things, and again, I always check them. If you look at this one, hopefully it'll focus. The capacitor is a bipolar cap. It's non-polarized. So there is no plus and minus. It is electrolytic, but it's non-polarized. So if you put a polarized capacitor in there and you have an alternating current signal, an AC signal, you will damage the capacitor, because when it goes into reverse polarity, it'll act like a dead short, which will heat the capacitor up. It'll cause a short on the power supply and cause damage. So you always want to make sure you replace that with an appropriate replacement. And while I was getting that one out, I also got one of these, because this one over here is also going to be non-polarized. And of course, this is one of those green ones. And like anybody on the internet will tell you, these non-polar capacitors are superior because they're green. Just remember that. Here's another interesting feature they put on this, and I've only seen this a couple of times. I have not seen this in very many receivers, although I have seen it before. This copper piece that slips over the speaker protect relay, if you look inside, right here and right here, you have two magnets. And those magnets, well, when we put them in there, they position themselves right over top, like this, on either side of the contacts. And the purpose for that magnet is those two magnets create a magnetic field that if the relay has to break the circuit, so when the amp is running under high power, for instance, and the relay has to break the circuit, what normally happens on these is you draw a great big arc, and that's what kills the relay contacts on this thing. Now you remember, I tested these relay contacts and they were absolutely perfect. And part of the reason was those magnets. The magnets actually disrupt that arc flash. Believe it or not, it suppresses it. I don't know why you don't see that more often in other amplifiers, but I have seen that before, and that's a good idea to do. Like I said, this thing has a lot of good ideas in it, but the execution of it was terrible. I mean, just the way they assembled this front part to be able to get to the controls, and this whole front part is bad. This whole back part is good. Again, I'm not crazy on this rail switching thing, the voltage switching, but, they did a couple of good things and some bad things. Well, so as it turns out, the contacts on this relay are perfect. Like I did in previous videos, I connected a 24-volt power source to energize the relay contacts, and then used the Keithley 197 in Kelvin mode and verified that it was just a few milliohms. So no need to replace or to try to clean the contacts here. So I'll put that back in. The power supply one seems to be okay as well. We have all the capacitors replaced, and I think we're ready to move over to the amplifier. So I'm getting ready to do the amplifier board, and believe it or not, these actually have been replaced, these two capacitors here. C714 and C716, and you kind of see where they cleaned up around it and some fingerprints on there, and you could see where the solder mask has been scraped away. So these were replaced, and these are the power, kind of the filter capacitors for the incoming power. So if you look on the schematic here, and I don't know if you can make it out, but C714 is right there. It's 100 microfarad, 100 volts, and C716 is 100 at 100, and it's down here. So it's on the positive and negative rails. So, and they were 100 microfarad, 100 volt, and these were 100 at 160 that they replaced. And like I said, this one feels a little bit bulged. I don't know, so it might be going bad as well. So I'm going to replace this with a nice set of Worth 105-degree caps also. And so there we go. Yeah, these were definitely replaced. I don't think any other ones have been replaced on here. So I guess this did have some service done on it at some point in time. But so far, that seems to be the only thing that they've done on this thing. But of course, as we get into some of the other boards here, maybe we'll find some other things that were done. Okay, that eats up a lot of solder wicks, so we're going to use the desoldering pump. This is your most economical way to remove solder from boards without having to waste a lot of wick. The wick is good for certain things. And of course, if I want to use the noisy station, I can do that too, but all right. So I'm going to need to form these leads a little bit. They're cut down already somewhat. So let's see. This one in here. Got a little overzealous with that. There we go. Tack one side in, and then we'll straighten it out and tack the other side in. This transistor must get really warm or something and cause these things to wear out. I don't know. It's just strange that that's the only thing that was replaced on here. I mean, I guess that's possible. But like I said, I tested a few of those blue caps that I took out, and they didn't read too bad. I mean, they definitely were not, they were reading a little bit higher capacitance, and I didn't check leakage. So even though they test good on the ESR, they had a higher ESR than the new ones, but nothing I would consider would be, you have to replace right away. But they that doesn't mean that the caps don't have any leakage in them. You really have to test all those parameters if you really want to test a cap. And I'm not testing them just so I can put them back in or reuse them, but it kind of gives you an idea of the failure modes of this thing. If you were just doing this for a customer, you'd just replace the caps and you wouldn't worry about testing anything or anything like that. Just replace them and move on. A lot of people say, why are you bother testing them? I just replace them. Good, that's what you should be doing. But how do we learn if we don't show some things on these videos, So that's why I do it. Both so I can learn and so you can all learn with me. So that's kind of my take on it. Okay, so let's replace the rest of them while we're here. And see what I did? I didn't check this one before I finished. Does that really matter? No. But I just kind of like them to be a little bit more even, I guess. That's good. Okay. So now we're going to boy, there's quite, you know, this amp has more, this receiver has so many capacitors. See that one, look how dark that one is. That one's like cooked. So let's take this one out next. I have a feeling it's not good either. Negative is facing the outside of the board there, but these ones are pretty well marked. Yeah, and they've all been correct so far too. There we go. All right, what is this? This is 4.7 at 35. Let's give it a quick test. Inquiring minds want to know. Let's see here. Well, 4.5 microfarads. That's not bad. And that's even at 1 kilohertz testing it. Well, oh, never mind. You got to put it in. There we go. Now we can switch through. Yeah, ESR is pretty high. See how high the ESR? Of course, this is 4.7 microfarads, and you're testing it at 1 kilohertz. There's 100 kilohertz. That's good. So believe it or not, even though this has that kind of scorched look on it, it still reads good. And this is kind of what I've been seeing all across the board on these. These caps have held up really well over the years. Very interesting. So if somebody would have just purchased this and used it, it probably would have performed pretty well. So let me find a 4.7 at 35. There we go. 4.7, 35. Okay. Now when these leads are real close together like this, I kind of like to bend them out and line them up with the holes a little closer. It just kind of puts less strain on the cap. Again, if you don't have time for it, because this is a job for a customer, you'd just kind of bend them out, make a Y out of it and shove them down in there and it'll still work. But if you have time and you want to be neat, then you can do it. When soldering, I noticed another, I see a lot of people that are just starting with soldering. Kind of a rookie error is not applying the heat and the solder and everything correctly. So let's do another one here, and I'll explain what I'm talking about. Let's do this one right next to it. I'm not doing this in any particular order. Let's see, take that out. We'll clean it out. All right, and what is this? This is a 100 at 50. 100 microfarad, 50 volts. It's probably perfect. As a matter of fact, that one appears as though it may have been replaced as well. Can't guarantee that, but kind of looks like it. So I saw another one on there, so I grabbed two of them. So 100 at 50 volts. And those ones line up pretty close, so I don't have to bend them with the pliers. All right, so what I'm talking about is the first thing I do usually start out with a clean tip. You don't necessarily have to do that, but I'm just kind of used to doing that. And what I do is you want the tip to touch the pad, at least the way I've done it for years, touch the pad and the lead at the same time, so you're delivering the heat from the iron to the joint. and then you present the solder to it, and it'll flow in there. You see that? It'll kind of bubble. And you should get kind of that cone look to it. It shouldn't have any kind of craters in it or anything like that, and it should be very shiny when it's done. I see a lot of people try to put it on here, you know, and then, or they won't get a good contact to the pad or to the lead or something, and the solder will all flow to one point, but it won't flow down on. You really have to make sure you get that. Just think of this as a heat sink, and you want to get a good contact between the heat sink and the heat source. So you kind of put it like that, and just, you want to get a little bit on the tip, and there you go. Now, normally it goes even faster than that, but when you're explaining things, but I can assure you, you can go pretty fast. The other thing is then follow up with a cotton bud and some isopropyl alcohol or some anhydrous if you want. Anhydrous is my favorite to use just because we keep so much of it for work, but anhydrous just means it has very low, almost zero water content, so it won't leave any kind of a residue. Now, normally for stuff like this, that doesn't matter. Some of the things we work on at work, though, you can't have any kind of residue or streaks from the water content at all. And it very specifically asks that you use the anhydrous. Okay, so there you go, and it should look like that when you're done. You shouldn't be able to tell that you were even there. Whoever did that those caps before did a fantastic job. You almost couldn't tell that they had replaced it, and that's how it should look. So, okay, here's a couple more of these, and I think these are 100s at 50s also, and actually there's two more, so I'll have to replace two of them. So let's get those out. See what I just did? I just moved that, and did you see that trace came loose? And that's what I was talking about on these boards. These boards are very delicate. You have to be careful not to overheat the board and not to move the component while it's still hot like that, or you end up with you know, pushing the trace out. So see, this one's kind of loose now. It should be okay. It'll tack back down, but you kind of have to be careful of that. And we're going to have to be careful when we put the lead in. That's why I don't like I said, I'm not a big fan of this series of receivers by Technics. They just don't have the build quality of some of the other gear that was being produced at that time. Again, I don't say that to offend anybody who likes this gear, because I like it as far as performance. It does a really good job. And I just when I see these boards, it's like there we go. The Harman Kardons of this era were also built like that. And they're a nightmare to work on the boards, because if you overheat the trace, they lift very easily off the board. And they crack. The other thing is those traces are so thin on those ones, on the HKs, that you'll get little micro cracks in a board and you can't even tell. And it can really wreak havoc when you're trying to work on these things, because if you've ever tried to troubleshoot one of those cracks on the board, it's really difficult because they're so small you can't see them. So I don't know why they put the minus symbol so far away on that, but and you notice a good board layout, you know, when they lay them out right, a lot of times you'll see the capacitors, almost all of them, the polarity will face the same direction. See how they did that on this? See, the negative side of the cap on every one of these is facing that way, pretty much. It's really cool. Not every board out there is designed that way, but that's what it is. All right. Did you see that cap move on me? There we go. Okay. Again, you know, you don't have to make them perfectly straight like that. That's just something I'm doing right now. And when you do that, you know, if you're doing for a customer or if you're refurbishing one for a friend or somebody, you know, it shows when you do that those little extra finishing touches. And you clean. Again, the flux in this solder is not corrosive. It's called no clean flux that they use on it. So if you left it on there, it wouldn't hurt anything, other than it just looks ugly. So when you clean it off, it just makes it look more professional. All right, so let's go to this one here. We'll replace that. What is that? 33 at 16. Okay. Let's do the 33 at 16. All right. You all bored yet? Sometimes these videos can bore the crap out of certain people. Other folks enjoy this. So for the other folks that enjoy this, this is for you. For you that don't like this, don't worry, some other cool ones will be coming up here soon. We'll get into a little more technical things. You know, it's surprising. I do get a lot of viewers who are very new to this hobby and have actually said they learned some things from these videos, believe it or not. So I do try to do some things like this from time to time to give you an idea, you know, of how to do some of these things. And again, I'm by no means a total professional at it. This is an amateur thing for me. It's a hobby. And but I share with you what I do know. And others share on the channel with me what they know, which is good. One thing I'm not a big fan of is just spouting out how many years you've done something. I've been doing this for 35 years, you know. And honestly, in my own personal experience of time, the more years you've been doing something, the more years you've had to forget how to do it. And what I mean by that is you may have been doing this for a really long time, but you may have forgotten some things the way you learned, you know, the right way to do them many years ago, because it's been so long. At least that happens to me a lot. Or you may have learned something one way and didn't realize that there's other ways to do it. So I try not to do that myself. It doesn't matter how long I've done something. I'm always looking to what other people, you know. An interesting story, and I don't know if it's true or not. I was told it was true. If any of you are into rock music, when Ozzy Osbourne broke off of Black Sabbath and he started, you know, kind of went out on his own, his first guitar player, Randy Rhoads, came from Quiet Riot, which ended up having a pretty good run of it themselves, even without him. But he was a phenomenal guitar player in the rock industry, you know. Anytime you talk about rock guitar, you start out with Jimi Hendrix and so forth, and Clapton and Jimmy Page and Ritchie Blackmore, all those people, but he was up there with all of them. And to my understanding, when he would go on tour, he would go find the local music store, and he'd just go in and take a single lesson off of whoever the instructor was there randomly. He didn't do it to be cocky and to show off. He actually went there to see what they knew and to see if they had anything that they could offer to him that he could learn. He never looked at himself as, to my understanding, what I was told, as someone who was a know-it-all. And I don't know if that story is true or not, but if it is, I have absolute respect for what he did. I think, again, he died way too young. People, no one should die that young and leave this earth, but I agree with that. I don't care how smart you are. You can still learn from others, even people who've been doing things for less time than you have. So really, the next time you go to say, I've been doing this for 40, 50, 30, whatever years, remember that that's okay. You might have been doing that, and you may have a lot of experience to offer to others, but you still can learn. That's the bottom line. So some of the best lessons I've learned were from people who've been doing things a lot less time than me. So especially at work, really just everybody's got something to offer. Look, that trace lifted on that one now. How annoying. Clean this up here. I do not like these boards. Not my favorite. Hello. There we go. Okay. 33 at 16. Get a couple more of those out, huh? So, yeah, that's kind of where we are with all this. Now, I'm burning up a lot of time in this video doing this little chat, so I probably won't get into a whole lot of technical stuff in this. Maybe I'll do a part 2 to this one and post it and kind of show you the finished product. Like I said, I'm probably not going to recap the tuner. We're going to do the alignment on the tuner, and if we have problems with that, then I'll go through and do the alignment, but I don't think that's going to be necessary, or go through and do the recap, I'm sorry, but I don't think that's going to be necessary, really. I think it'll work okay. These caps are testing okay, and I just don't put super high value on this, even though the next model up from this, the SA-1000, is legendary. But if you look at any of the pictures of the circuit boards on the SA-1000s, it's different circuit board material and so forth. It's a lot better build quality than these. I think these ones were just made to have the same specs as the more expensive ones out there and compete and, get the sales. That's what I think this thing, how it was built to a cost. But, I mean, the transistors and everything are good. I mean, they're good quality. So, what do we have here? These are going to be the audio grade caps at the input. So let me get a couple of those out. I'll be right back. All right, we'll go with some Nichicon Fine Golds. I had those here. Those are getting scarce. I think some of those are no longer being produced. I'm not sure, but I believe they have stopped making them. I could be wrong, but I've noticed you don't see as many of those available for purchase anymore. There we go. So you know, it's kind of the era we live in. Sooner or later, what you're going to be doing is you're going to be using surface mount caps, you know, because they still make good quality surface mount caps. And you're just going to have to adapt them to work on through-hole boards, making little adapter PC boards, teeny tiny ones, or tacking little leads onto them or something. You'll have to do something to make it work. I mean, it's just kind of the era we're in right now, because manufacturers just aren't going to keep producing these things forever, because there's just not enough of them out there to you know, to make the sales. Because, you know, you might say that, yeah, there's millions of pieces of audio gear out there that are still being refurbished, but you got to realize not everybody's refurbishing them. And, you know, when they produce these capacitors in the factories, they're probably making them in the tens of millions. Who knows? I mean, just large amounts of caps. So if they can't make them in those kind of quantities over periods of time, it's not worth them tooling up to make them. So I think that's why you start seeing them die out, unfortunately for us. And then you got people that are hoarders, and when they quit making them, they buy every one they can possibly get, more than they'll ever use in their own lifetime. And then they end up sitting in somebody's bins, and those people pass away, and those caps, people don't know what they are, and they're lost. So while I do keep a good stock of things, I try not to hoard everything. I already have too much stuff as it is, but only because of the amount of things I work on. So I have a lot of different parts, you know, because I don't just do the stereos. I do radios and things like that. Of course, all of the X-ray equipment and power supplies and things at work that I work on, and computers and different things. I just had to rebuild a very unique kind of LED control board, because the board's really expensive and hard to get from the manufacturer. And all that really goes wrong is there are some Schottky diodes that go bad, so you got to replace them. And they're not real easy to find, the type of them, so you have to find an alternative, which I've done, and you know, and they're using the lead-free solder, which is a pain to work with. So yeah, all right, it's all recapped. So I think we can put this together and test it out. Okay, as you can see, I've taken the faceplate off to clean it, because there was some dirt on the dial glass, on the faceplate glass, I should say, that needed to be cleaned, and some dust in here. And I was thinking of possibly cleaning the controls, but after looking at this, wow. This receiver, in my opinion, just, this is an opinion thing, it gets a fail for me. This is extraordinarily difficult to take apart. If you look, there are screws coming through the top of the board, here and here. And they go through the board and into this frame, so you can't really get the board out because this thing is in the way, and it's held in with a whole bunch of, it's one solid bracket. You really can't take it out of the way. Okay, for those of you who do desire or have the will to do this, here's the exploded diagram. There's 2 pages. There's this one. You can see that. That's to get the outer part out. And here's the other one. And you can see they don't even show this bracket right here coming out. But if you look at what I'm saying, this piece here has to come off to access the board. But if you notice, it wraps around here and screws in through the top to these other pieces, which you have to take out, which all of that mess I'm just not going to do. It can be done. I mean, if you really want to tear this all out, you can do it. Just the time and effort that I would have to put into this in order to do that would really kind of offset the value of it. And especially since it's working, I'm going to leave Sleeping Dogs Lie on this. So this will go as a partial recap, you know, amplifier and power supply recap. Everything else original. I was able to get some cleaner into these at least, and this one here I'm probably going to have to get the long hose, the colonic hose as we call it, and go way up in through there if I can, if it's even possible. You can see how difficult it is to get in there. I mean, you really just can't even get to it. So I'll see what I can do. A couple of these I can actually access, like down here through these openings. I can get into a couple of these, but some in the volume pot I can maybe get into that. That one will be okay. This switch up here, right here, going to be very difficult. And like I said, wow. So when you see this, I'll have the faceplate on, and that's going to be it. In addition, you see this white crust here. This is glue. These cheap plastic things have broken at some point in time. It looks like somebody tried to glue them on, so I'm not going to try to pull these off because I think they'll just crumble. All right, so I'm all done putting it all back together. And this was pretty much a solder and chat video. I wasn't getting into a whole lot onto this. But what we'll do is, as I said before, this has some unique features, and part of it is the alignment procedure. So what I'm going to do is I'm going to end this video here, and then we're going to come back and we'll do the alignment on a separate video. It should be a rather short one, but we'll go through it, and maybe I'll even show some highlights of doing the alignment on the tuner, because I thought that was kind of cool too, how they do it. It's mostly straightforward, but they kind of have a little different approach they use, which I think is pretty cool. So we'll do that as well. So until next time, I wish you all peace, joy, happiness, and good health in your lives. And we'll get this thing up and running. And like I said, it's a shame that the front end of this thing is so hard to work on, because the rest of it, it's not a bad amp. I mean, I really don't like that power switching thing, but everything else, I think this wouldn't be a bad receiver. All right, we'll see you again. Take care. Bye-bye.